There is an imaginary line in the middle of the Pacific Ocean where if you cross it, you literally jump forward or backwards an entire day. It's the international date line. Let's explore this. Hello everyone, welcome back to Star Stuff. Today we're going to talk about the strangest and most fascinating features of our world, the international date line. And no, it's not a number you can call to go on dates internationally. Let's break down why it exists, how it works, and why it only works on a globe. The International Date Line, or IDL, was established in 1884 and isn't a physical line you can see. It's an agreed upon boundary that runs roughly along the 180-degree longitude line in the Pacific Ocean. If you stand on one side, it might be Monday morning, but just a few kilometers away, on the other side, it's already Tuesday morning. That's a whole 24-hour difference in the same moment of time. The Earth is round and rotating, and it takes 24 hours to rotate once. As it spins, different parts of the world face the sun, and that's why we have time zones. Think about sunsets and sunrises. The sun doesn't rise for the whole world at once. It rises gradually as the Earth rotates. So people in New Zealand will see the sunrise hours before people in California. Without time zones and the dateline, our clocks and calendars wouldn't match the cycle of day and night. Now, you might notice that the line isn't perfectly straight. It zigzags around islands and territories so that entire countries can stay in the same date. Imagine how confusing it would be if half of Fiji was on Tuesday while the other half was still on Monday. So here's where things get really interesting. Flat Earthers often use the AE map as their go-to flat Earth model. On that map, the longitude lines spread out like spokes of a wheel, and they never meet at the South Pole, because in their model there is no South Pole. That creates a huge problem. On the globe, the international date line works because it's directly opposite the prime meridian at 180 degrees. But on the AE map, 180 degrees isn't opposite anything. Every longitude line just ends up at the outer edge. So if you try to draw the international date line on their map, it wouldn't run neatly through the Pacific. It would have to wrap around the entire outer edge, causing contradictions where distant countries would supposedly share the same date and time. In other words, the date line collapses completely on a flat Earth. Only makes sense on a globe. Here's the clincher. Longitude lines or meridian lines all meet at the North Pole and the South Pole. On a flat Earth map, they just fan out forever. But in reality, they converge. That means if you're standing exactly at the pole, time zones become meaningless.
You see, at the North and South Poles, all the lines of longitude converge. This creates a unique situation where every time zone on Earth meets at a single point. And what it technically means is that if you were to stand at the exact North or South Pole, no matter which direction you faced, you'd be in every time zone simultaneously. However, this phenomenon doesn't really affect the work of the polar explorers or the scientists who live there. To simplify matters, some of them use a single time standard known as Coordinated Universal Time, and others choose to use the time zone of either the closest point of civilization or their countries.
You could technically step around the pole and cross all 24 time zones in seconds. The system only makes sense because the Earth is a sphere. As the planet spins, time zones wrap around it like orange slices, meeting at the poles. The date line is simply where those slices reconnect. On a flat Earth, you wouldn't have consistent sunrises, sunsets, converging meridians, or a single line where the calendar flips. The international date line is one of those quiet but powerful reminders that our world is in fact spherical. So next time you check the clock and you see it's tomorrow somewhere else in the world, remember that's not magic. It's the Earth rotating, giving us sunrises and sunsets while the meridians converge, and a clever way to keep time in sync. Thanks so much for watching. If you enjoyed this video, please give it a like and subscribe to Star Stuff and click the bell icon if you don't want to miss out on any more deep dives into the science of our universe. Until next time, please keep learning. Cool beans.